Hi, everybody. Good morning. Hey, guys. So you guys should all have this review. I sent it to you last night, but just in case you don't, I'm going to go ahead and upload it again here on the chat. Give me a second. How are you guys doing? How's everybody doing? Good. You guys ready to begin? You know, but we're here, right? So we're here, and we're getting close to the end here. So let's finish strong. Let's take care of this review, and then I'll go ahead and open up the midterm afterwards. Okay? And I will give you guys a lot of time to do it, seeing as I want to make sure that we get this one done, no problem. But in the future, we probably will have to stick to the time. We will have to stick to the time allotted. So the midterm, I'm going to let it be open for one day. I think one day or 2 days. I haven't, whatever, probably it'll be due tomorrow by midnight. So I'm going to open it as soon as we're finished with class. Okay, any questions before I begin going over the problems? Okay, great. All right, everybody have a copy? All right, so let's go through this. So okay, so the amount of time it takes for Emma to wait for the train is continuous and uniformly distributed between 4 and 11 minutes. What's the probability that it takes Emma more than 5 minutes to wait for the train? So so basically it's a uniform distribution, right? So X is uniformly distributed, and it goes from 4 to 11. So the lowest point is 4 and the highest 11. So if you recall, for uniform distribution, the function is 1 over b minus a, where this is a and this is b, okay? And then if you recall the graph, it's a straight line, right? This is f of x, okay? And it goes from, it's basically an area that goes from 4 to 11, okay? And the width, so it's basically you want the area underneath the curve, or in this case, the curve is just a straight line. So really what we want is a base times height situation, the area of this rectangle. So the probability that x is greater than 5 is going to be e minus a. So so in general, probability that x is greater than some value, and I guess we could call it see here. Actually, we want this 5. This is not filled. This is filled in. So let's call it, I guess, DC. We'll call it, no, we'll call it D. It's this 1 over, so 11 minus 5 is the base here. So 11 minus 5, okay, so it would be, in this case, it's B minus D, okay, D. And then the height is the f of x. So in this case, it's 1 over 11 minus 4, which is 7. So 1 over b minus a, okay? So in here, it's 1 over 11 minus 4. So that's just going to be 6 times 1/7. And your answer is 6 over 7, okay? So that is number 1. Okay, any questions on this? All right, so continuing, number 2, the diameters of apples from a certain farm follow the normal distribution with mean 4 inches and standard deviation 0.4 inch, fourth of an inch, or 4/10 of an inch. First, the apples are rolled over screen with mesh size 3.5 inches. This separates the diameter, all the apples with diameters less than 3 inches. Second, the remaining apples are rolled over screen with mesh size 4.3 inches. So find the proportion of apples with diameters less than 3.5 inches. So you want to find the area under the curve of apples less than 3.5. So for this one, we use our calculator because we don't know the function, okay? And but we do have mu, and we do have sigma, and we also know that it's normally distributed. So since it's normally distributed, we would use the normal CDF function. And it's going to go to the left, right? Because it's less than, so it's negative 999 comma, and then it's 3.5, and then it's the mu, which is 4, and then the standard deviation, which is 0.4. So go ahead and do that on our calculators. Okay, so here we go. We have second distribution, norm CDF. So you see here, normal CDF. Okay, and then our lower value is going to be negative 9999, comma, upper value is 3.5, comma, mu is 4, comma, and standard deviation is 0.4. Okay, so your final answer would be 1.1056. So round your answers to 4 decimal places. So it would be the proportion of apples with diameters less than 3.5 inches is 0.1056. Okay, so this would be the answer that you enter. Okay. Any questions? Okay. Okay, so let's go on to number 3. So Eric wants to estimate the percentage of elementary school children who have a social media account. He surveys 450 elementary school children and finds that 280 have a social media account. Okay, so this is like a proportion problem where you have a p hat. Okay, so the random sample is 450. So n is 450, and then x is 280, right? Because that's how many have a social media account. So our p hat, remember it's x over n, so that's 280 over 450. Okay, so this approximately becomes 0.622. Now we want to do the confidence interval, right? So we also, it asks for p prime. So p prime would be 0.622 because it's 3 decimal places. And then they want to know the standard error of P prime. So recall that the formula for this is the square root of P prime times Q, or 1 minus P prime all over N, okay? Or also, this is also Q prime. So, so then you would get the square root of, and then you have P prime. 1 minus P prime is the complement. So that's point, what is that? So 0.622 minus 1 minus 0.622, so 0.378. So 0.378, and then all over N, which is 450. Okay, so that is your standard error. And then if you calculate that out, that's going to be, let's see here, where did I put my value? It didn't, I guess I didn't write that. Okay, so let me go ahead and calculate that. So you would do second square root, in parentheses 0.622 times 0.378 divided by 450, enter, so 0.0229 or something, 0.0229. And then what's the formula for, you need to find the confidence interval, you need the margin of error, right? So the margin of error is going to be, so remember for confidence interval, it's your point estimate minus the margin of error, point estimate plus margin of error. But what's the formula for margin of error? It's the critical value of z, or in other words, z of alpha over 2 times the standard error. Okay, so we have our standard error. We just need the critical value of z. So and that's reliant on alpha. And alpha, remember, is the complement of the confidence level. In other words, the confidence level plus alpha is equal to 1. So if this is 0.99 plus alpha equals 1, this implies that alpha is equal to 0.01. Okay, so if alpha is 0.01, alpha over 2 is going to be 0.005. So what is z of 0.005? That's right here, right? So we have this nice chart. So this z of 0.005 is equal to 2.576. So we plug that in, 2.576 times the standard error, which is 0.0229. Okay, so times 576. So your error is 0.059. Okay, all right, so now you have everything. You have E, and you have your P prime. Okay, so and you have your standard error. So 0.0229, and then z of alpha over 2 is 2.576, and then your confidence interval will be 0.622 minus 0.059, comma 0.622 plus 0.059, and that comes out to 0.563, comma 0.681. Okay, now, do you guys have any questions on this? No questions? Well, okay, well, just in case, if you wanted to check yourself, you could always use, since this is a proportion, you could use the function on your calculator, 1 prop z interval, and to do that, all you need is the successes over n and the confidence level. So that's kind of nice. So in our case, it was 280, n was 450. and then the confidence level was 0.99. So as you can see, 0.563 is our lower bound, and 0.681 was the upper bound, so we were correct. We'll check with one prop z int on the calculator. Now you might ask, well, why didn't we do the whole problem using this? Well, that's pretty easy to answer because we don't have a standard error in, it doesn't give us standard error. It does give us the confidence interval and it gives us P prime, but that's about it. Okay, great. All right, so let's continue to number 4. The average American city has 50 buses that use green energy with a standard deviation of 5 buses. A city planner is interested in the sample mean, okay, number of buses for a sample of 30 cities. He calculates that mu of x is equal to mu over m, and sigma of x bar is equal to sigma over square root of n, square root of n. And what did he do wrong? So for this one, remember that we're talking about sample mean, and so he has calculated the, remember that for the sample mean, mu of x is equal to mu. So that means that mu of x should have been 50. So he did the mu wrong. So this is what was wrong. But however, this is correct. You know, so what he did was he had the mu x bar wrong, but he calculated this correctly. He should have had 50 and then a sigma of x bar is 0.91. So it's B. Pretty straightforward. And how did I know to use this? That's because of the sample mean. That was the hint in that we use the central limit theorem for mean. Okay, so that's number 4. So let's go on to 5 unless there are any questions. Okay, 5. So the amount of time it takes Jolene to wait at the bank is continuous and uniformly distributed between 9 minutes and 19. What's the probability that it takes Jolene less than 11 minutes given that it takes less than 14 minutes for her to wait in line at the bank? So it's a uniform distribution. So it's one of these deals. However, it's given that it takes less than 14. So meaning that you know it's going to stop at 14. So remember, when you have a conditional probability, it changes your sample space, right? It changes kind of what you're counting over, okay? Because it limits your sample space. So instead of going from 19 minutes, you're actually considering it from 14. Okay, even though originally it's uniformly distributed over this interval, because of this condition, you're actually going from 14, and it changes your f of x as well. Your f of x is going to be 1 over 14 minus 9, okay? So the function is going to go from 9 to 14, and the height of it is going to be 1 over 14 minus 9, which is 1/5. And then what we care about is that the probability that it takes less than 11. So here's 11, and we care about this area under the curve right here. This is the area that we care about because it's less than 11. That's what we're looking for. So the area for this is going to be base times height. So the base is just 11 minus 9, and the height is going to be 1 over 14 minus 9, or 1/5. And that's just 2 times 1/5, or 2/5. Okay? Yep, so that's it. So you would just answer 2/5 because it says to provide as a fraction. Any questions on this one? So we've seen these problems before, I'm sure. Okay, so then number 6. The following data represent a random sample of the ages of players in a baseball league. Assume the population is normally distributed, and we have a standard deviation of 1.8. And then it says find the 95% confidence interval. So we want to find, so our confidence level is 0.95. Okay, and for this one, all we need to use is the function z interval. Okay, so we do stat, and then it goes to test, and then it goes to, we choose z interval because we're trying to find the confidence interval. So let's go ahead and do that. So let's see here. So let me put out of this, clear. So stat, test, z interval is just one sample. Okay, and we're given, oh wait, actually we're given a list, so we need to enter that first. So first thing is enter into L1, this list, okay? So stat, edit, I'm sorry, stat, edit, edit. So we're gonna clear this. This is from the last class. So 32, 24, 30, 34, 28, 23, 31, 33, 27, 25. So I've entered it in, and then I go stat, test, z interval. Wait, oops, my bad. I was supposed to exit out here. Okay, so now stat, test, z interval. And I have here my standard deviation. It asks for your standard deviation. Well, that's 1.8. That's given in the problem. My list is L1. My frequency, my confidence level is 95%, so 0.95. Okay, great. Then I just calculate it, and I get my interval here. So my interval is 27.58, comma, 29.82. Okay? Questions on this? Okay. Yeah, so that's pretty much it. Very straightforward. And just make sure you round to 2 decimal places. And that's number 6. Okay, let's continue. Sorry, I have like a bunch of papers here. I don't know if I'll be able to get through everything, but I'll try my best. Okay, so, and the actual exam is not going to be this long. I don't think. So Z, suppose the number of inches of rainfall each year is normally distributed. For a random sample of years, the confidence interval is generated. Find the margin of error. So remember, what this you need to do, you need to remember, if you're given the confidence interval, the error is equal to the highest minus the lowest, right? Divided by 2, because the error is like the distance from the center, okay? So remember, the midpoint is the actual point estimate, x bar, or whatever it is that you're talking about. So, so error would be 7.7 minus 3.9, and that's divided by 2, and that ends up being 1.9, and that's it. So, you know, your answer is just 1.9. Okay. Okay, great. And then for number 8, the random variable, it has a uniform distribution with values between 17 and 20. What's the standard deviation of X? So for a uniform distribution, okay, the standard deviation is equal to B minus A quantity squared over 12, okay? So we just plug that in. Well, what is A and what's B? So A is 14, B is 20, and that's pretty much it. It's just plugging it into this formula. So we have here 20 minus 14 quantity squared over 12, and then you just take the square root of that. And when you take the square root of that, you get approximately 1.732, because it's the nearest thousandth, so that's tens, hundreds, thousands. That means 3 decimal places. So your answer will just be 1.732. Okay. All right, so then for number 9, it says Evelyn wants to estimate the percentage of people who own a tablet computer. She surveys 150 individuals and finds that 120 own a tablet computer. Use a calculator to find the 99% confidence interval. Yeah, so again, this is a one prop Z interval situation, because this is a proportion. So she has n individuals and she finds that 120. So we have here that x is equal to 120. The number of people in the sample, or the people that are surveyed, is 150. And then we have our confidence level, which is 0.99. And really that's all you need in this function. So let's go ahead and do that. So let's clear this. So stat, we have here one prop Z int. So you just do stat, tests, one prop Z int. And you're basically finding the interval given one proportion. So your x is 120, your n is 150, your confidence level is 99, and then you just calculate it, and there it is, boom. So your final answer should be round to 3 decimal places. So 3 decimal places. So you would have 0.716 and then 0.884, and that's it. That's really all you need to have right here. Okay, so yep, so that is for number 9. Does anybody have questions on this? Okay, so okay, if there's no questions, I'm just gonna keep going. All right, so number 10 is next. Let me just straighten myself here. Okay, so suppose that the delivery times for a local pizza delivery restaurant are normally distributed with an unknown mean and standard deviation. A random sample of 24 deliveries is taken and gives a sample mean of 27 minutes and a sample standard deviation of 6 minutes. Okay, so that's a lot of info, but then it says the confidence interval. It gives us the confidence interval. So again, it wants to find the margin of error. So the margin of error is this, so it's the same kind of problem. So given a confidence interval, the margin of error is just highest minus lowest over 2. Now, if they wanted to find the mean, the sample mean, then you would have to do the midpoint, which is plus. But when it's error, it's subtraction. So that's just 29.53 minus 24.47 divided by 2. And so my error is going to be, we need to give it to 2 decimal places. So plugging that in your calculator, you will get 2.53. Okay. So yeah, so feel free to, if I'm going too fast, feel free to slow me down, but I think we've seen this before, so. Okay, so in a random sample about advertising preferences, 17 out of 40 individuals say they prefer print over digital. So use the +4 method to find a 99.7 confidence interval. I think we've gone over this one before, if I'm not mistaken, but just in case, so remember +4, what that means is we add we basically create 4 more trials where 2 are successes and 2 are failures. So your new P prime, or your new point estimate, is going to be x plus 2 over n plus 4, okay? So our x is 17 and our n is 40. So that's just gonna be 17 plus 2 over 40 plus 4. That's just 19 over 44. which is approximately 0.432. Okay, and then what's my alpha? So my alpha, why is that important? Because we're gonna need to find the confidence interval, 99.7. So the confidence level is 0.997, which indicates that the alpha is 0.003, as these two added together need to equal to 1. So if you recall, for the error of a proportion, it's going to be, it's the z of alpha over 2 times the square root of p prime q prime over, in this case, it's n plus 4 because we're doing plus 4 method, okay? So we need this z alpha. So we have a p prime. So if this is p prime, that means that q prime is 1 minus this. So it's going to be 1 minus 0.432. So 1 minus 0.432 is 0.568. Okay, so we have p prime, we have q prime, we have n. We just need this z of alpha over 2. So luckily we have this chart. Okay, so if alpha is 0.003, that means that alpha over 2 is 0.0015. I just divided this by 2. So what is z of alpha over 2? In this case, that's z of 0.0015, or the z value that corresponds to this alpha over 2. And that happens to be 2.968. Okay, so 2.968. All right, so then we just plug it in to find our error. So our error is 2.968, and then times the square root of 0.432 times 0.568, and that's all over n plus 4, which is 44. Okay, so we plug that in, and you will get to, does it say how many 3 decimal places if necessary? So 0.222. All right, now remember, we still need to do the confidence interval. What's the formula for that? Is p prime minus the error, p prime plus the error. Okay, so that's going to be, the confidence interval will be 0.432 minus 0.222, 0.432 plus 0.222. Okay, and that's just going to be 0.210, 0.654. Okay, so that's pretty much it. That's your that's what you put into here. Let's see, what else could we have done? Could we have done this in a shorter way? Yeah, could we have done could we have used the calculator to do this? Sure, or instead of x, we would have used, instead of our x, right? We would have used x plus 2, which is 19, and then our n, right? So I would just do x prime, or n prime, we would just do 44, and then when we have our confidence level, so that's 0.997. So I guess we could have done, to check, let's see, we do stat, test, 1 prop z int, and we would have done 19 over 44, and then the confidence level would have been 0.997, and then just calculate that. Yep. So you could have also done this. I guess, so there's more than one way to skin a cat, I guess. So that would be how to do that. So you could also do 1 prop z int on the calculator, and you would just use this stuff. Okay. So there's 2 ways to do it. Okay, so yeah, so that's it for number 11. So let's continue to number 12. So number 12, according to a recent study, the mean hours of college students spent studying per month was 75 hours. I'm sorry, my dog is so loud, it's super annoying. So the mean number of hours college students spent studying per month was 75 hours with a population mean of, a population standard deviation of 25 hours. 2 weeks before final exams were scheduled to begin, 100 college students were randomly selected. So it says here, use Excel. Well, that doesn't make sense. It says here, we should be using a calculator. I don't know why it says Excel. It should be calculator. So use a calculator. Okay, so to find the probability that the mean hours, so we have here, so the mean hours, 75, population standard deviation 25, and is 100. And we're trying to find the probability that the mean number of hours spent studying is less than 70. So we want this. Okay. So since we're talking about the mean, we're using central limit theorem for means, CLT for means. Okay, so this is the hint. And what is that? So the mean of the population is 75. So the mean of X bar is also going to be 75, right? That's by central limit theorem. Okay, and the standard deviation, the formula for that is 25 over square root of 100. In other words, it's going to be sigma over square root of n, sigma over square root of n in general, right? So, so what is that? So we have mu of X bar 75, and then 25 over square root of 100 is just 2.5, okay? And then we need to find, to find this, we use normal CDF. So the inputs are low, high, and then mean, and then this, right? So we would use negative 9999, and then we stop at 70. Then we put our mean, which is 75, and our corresponding standard deviation, which is 2.5, because we're talking about the means. So let's go ahead and do that. Okay, second, clear this. We're doing distribution. Okay, norm CDF, negative 999, comma, up to 70. Okay, 70, and then the mean is 75, and then the standard deviation for the means is 2.5, and that's it. So your answer will be 0.022275, but it says round to 3 decimal places, so it will be 0.023. Okay, so the probability that the sample mean is less than or equal to 70 is 0.023. So 0.023. So in this case, remember, it doesn't matter less than or equal to because it's an area. All right, so that was pretty much it. It was remembering central limit theorem for means. Okay, so next. Alice was told that her reading score was 1 standard deviation below the mean. Okay, so so Alice was, if test scores are approximately normal with mu is 86 and sigma is equal to 4, standard deviation is 4, what was Alice's score? So her reading score is 1 standard deviation below the mean. So really, that just means that it's 4 away from mu in the negative direction. So you could use, so 1 standard deviation, or you can do it where when it says 1 standard deviation below the mean, that implies that the z-score is -1. Okay, so you could use a formula to do this as well. But really, if the mean is 86 and the standard deviation is 4, one standard deviation below this is 82. So that's the quick way to do it without using the formula. But in this case, let's just go ahead and do it. So mean is 86, sigma is 4, and z score is -1 because it's below. So you just plug it in, 86.4. So that's multiply, so -4 is equal to x minus 86. And then when you add 86 to both sides, you get what you wanted. In other words, x is 82, which is what we said. So 82. So that's it for 13. So these aren't too bad. Okay, so in a recent survey, a random sample of 199 office managers were asked about overtime, and 76 reported that they regularly work overtime each week. So what value of z should be used to calculate a confidence interval with a 98% confidence level? So it's asking for what value of z, and it's giving us the confidence level. So remember, it's z of alpha over 2, basically. This is asking us what's z of alpha over 2 is what? Okay, so if the confidence level is 0.98, then alpha is the complement, which is 0.02. So alpha over 2 is just 0.01. So what we're really asking for is z of 0.01. Luckily, we have this table, so that's really it. So, you know, it's not too challenging. It's really just figuring out what the problem is. And then once you understand the problem, there you go. Okay, so yeah, it's pretty straightforward. Okay, so let's continue. 15, we have, let me just straighten out myself here. Okay, so a clothing store wants to determine the current percentage of customers who are over the age of 40. The store wants to create a 98% confidence interval, which has a margin of error of at most 2. How many customers should be polled to create this confidence interval? So for this one, because it's asking how many customers, it wants to know what n is. What is n? Okay, so we have here, let's write down what we have. We have the confidence level, which is 98%, right? So confidence level is 0.98, which means that you're really, the z that you're using for is alpha over 2. So that's z of 0.01, which is 2326. Okay, what else do we know? We know the formula for n. Okay, so from here we could find p prime. We have p prime. We don't know p prime, and we're not given p prime. So when we're not given that, we use the default, which is 0.5. Okay, because we don't know what n is. So of course we wouldn't have a sample value of p because it's x over n. We don't know that. So we use 0.5 by default. Okay, so really all we need to find, because the formula for n here is z squared p prime q prime all over the error squared. Okay, so we just need to find the error. So the error, but the error is given to us. The margin of error is at most 2%. So right away, we already know the error is 0.02. So really we have this, we have z, and we have p prime, q prime. Great, we can find n. So n is equal to 2.326 quantity squared times 0.5 times 0.5, and that's all over the error, which is squared, which is 0.02 squared. Okay, and that just becomes, you know, you do the calculation and you would get 3381.4. Okay, so if we round up to the next integer, because we're talking about people here, so that means it's 3382 customers, 3,882. All right. Oh, and I think this is a repeat. So we skip this. This is repeat. This is basically like quiz 8, huh? And then 17, In a recent survey, a random sample of 320 married couples were asked about their education levels. 41 couples, at least one of the partners had a doctorate degree. Find the value of Z that should be used to calculate confidence interval with 95%. Well, we could just use a table, right? So CL is 0.95, that means that alpha is 0.05, that means that alpha over 2 is 0.025. So really what they want is the Z of 0.025, but that's just, we could just use this table like up here. See, what's that? That's 1.96. So boom, we don't even need to, we don't need to go and find a calculator. We just use that. So so then I guess 960 since it's 3 decimal places. Okay. So use table. Okay, so that's 17. And then 18 is next. We have here the number of square feet per house are normally distributed with a population standard deviation of 137 square feet and an unknown population mean. So a random sample of 19 houses is taken and results in a sample mean of 1,350 square feet. So find the margin of error for an 80% confidence interval of the population mean. So we need to use the formula for margin of error for the mean. Okay, so so we have here what's given to us. The population standard deviation is 137. We know that it's normally distributed. We know that N is 19. And then we know that the confidence level is 0.8, so then alpha must be 0.2. So alpha over 2 is 0.1. So we need to find the Z of 0.1. So that's just going to be 1.282. And then remember our margin of error is going to, the formula for that is Z of alpha over 2 times the population standard deviation over the square root of the sample size. So that's just going to be plugging in your values. We have this, we have this, we have this, we have everything. Okay, so 1.282 times 137 over the square root of 19. And then when you plug that in, you just get 40.29 because you're rounding to 2 decimal places. So that's it. Pretty straightforward. Okay, so then we have number 19. Suppose pages per book in a library have an unknown distribution with mean 297 and standard deviation 25 pages. A sample size of n equals 75 is randomly taken and the sum of the values is taken. Using the central limit theorem for sums, what is the sample standard deviation for the sample sum distribution? So what is the central limit theorem for sums? So the standard deviation for the sample sum distribution is going to be the standard deviation times, or it's the square root of n times the standard deviation, okay? The original. So, so we have n and we have standard deviation. So n is 75, standard deviation is 25. So you just plug it in. So that's just going to be square root of 75 times 25. And that just becomes 216.51, which is B. So B. So not too challenging, pretty straightforward. So then let's do number 20. 20. Let me just, okay, here. 20. The finishing time for cyclists in a race are normally distributed with an unknown population mean and standard deviation. So a random sample of 25 cyclists is taken to estimate the mean finishing time. What t-score should be used to find a 98% confidence interval estimate for the population mean? Okay, so for this one, you basically just need to use a table, remember? And we need to remember for t distribution, degrees of freedom is n minus 1. Well, n is 25, okay? So that's just 25 minus 1, that's 24. So your degrees of freedom is 24. And then also, we need to know alpha over 2, right? So the 98% is your confidence level. So alpha is 1 minus 0.98. So alpha is just 0.02. But then alpha over 2 is 0.01. So we're looking for a t-score, t of 0.01 and degrees of freedom of 24. So here we go. So basically, where do these two meet? And so your answer is just 2.492. So 2.492. Okay. I guess you could also use a calculator, but not everybody has inverse t. So it's good to use a table. The function, for those that are just, that want to know, it's the confidence level, and the you would have to put here 1 minus alpha over 2, and then here you would have to put the degrees of freedom, so that's 24. So this one is degrees of freedom. Okay, so inverse t. Okay, so that's just if you want to, but you don't need to if you can figure this out. It's pretty easy. All right, so 21. We have here, Gail averages 150 points per bowling game with a standard deviation of 14.5 points. Suppose Gail's points per bowling game are normally distributed. But X equals the number of points per bowling game. Then, and X is normally distributed with, if necessary, round to 3 decimal places. So suppose Gail scores a number 108 points in the game on Thursday. The z-score is what when X is 108? Okay, fine. So the z-score, we just use the formula. Okay, so we have X, so Z is equal to X minus mu over sigma. So we're given standard deviation, and we're given mu, and then we just need to find X. We need to find Z, and here's our X. So, okay, so here we have 108. We have mu is 153, and then we have standard deviation 14.5. That's all given to us in the problem. So we're just plugging in stuff. So 108 minus 153 divided by 14.5. And that's going to give you a value of negative 3.103. And that's right here. So the z-score is negative 3.103. And then the mean is 153. That's given in the problem. This z-score tells you that X is 3.103 standard deviations to the left. So we don't put a negative here because it tells us that it's to the left. Yep. Okay, and then we have here, in a recent survey of 150 teenagers, 93 stated that they always wear their seatbelt when they travel in a car. Assuming the distribution is approximately normal, find the point estimate and standard error. Okay, so we need to find our point estimate, and then we need to find our standard error. That has to do with sample proportions. But we're given n and we're given x, okay? So remember that the point estimate, or in other words, the sample proportion is x over n. So that's 93 over 150. So that becomes 0.62. 93 divided by 150. And then to find our standard error for the proportion, that is the square root of p prime q prime all over n. Okay, so so p prime is 0.62. So if p prime is 0.62, that implies that q prime is 1 minus that. So that's 0.38. So your standard error is going to be square root of 0.62, 0.38 all over n, which is 150. Okay, and that approximately is, so you would do second square root, and then you would do 0.62 times 0.38 divided by 150. And that's, it says 3 decimal place, so it would be 0.0396. So 0.0396 actually rounds up to 0.040. Okay, so this is 0.62 and this is 0.040. Okay. So not too bad, pretty straightforward. All right. And then we have here number 23. Number 23. So suppose speeds of vehicles traveling on the highway have an unknown distribution with mean 63 and standard deviation 4 miles per hour. A sample size of n equals 44 is randomly taken from the population and the mean is taken. Using central limit theorem for means, what's the standard deviation for the sample mean distribution? So, so this one you need to remember CLT for means. So what does that mean? Mean. That means that the standard deviation for the sample mean is equal to the original, right? Distribution, the sample deviation, the standard deviation for the original distribution over the square root of n. Okay, so we're given all that information. We're given that the standard deviation is 4, and we're given that n is equal to 44. So it's really just plugging in. Okay, and that's approximately like 0.60, and there it is. So your answer would be B. So let's continue. So Liam wants to estimate the percentage of people who lease a car. Okay, so Liam, he surveys 240 individuals and finds that 54 lease a car. So find the margin of error for the confidence interval for the population proportion, right? So, so this one, it's we're using that formula. He knows P prime is, so this is N and this is X, right? And he's interested in finding the margin of error. So we're given that P prime is equal to 54 over 240. Okay, so that's approximately 0.225, or that's about 0.225. That just is, not about. Okay, so, and then we need to use the formula for margin of error. So that's Z of alpha over 2 times the square root of P prime Q prime over N. So Z of alpha over 2. So it's 95% confidence. So by now we should be like pretty used to figuring this out, right? If we know the confidence level, we know alpha, that means we know alpha over 2, and then we can use a table to find the appropriate Z. So Z of 0.025 is equal to 1.96. So then it's just a matter of plugging in stuff. So if P prime is this, that implies that Q prime is 1 minus this. which is 0.775. Okay, so just plug in P prime, Q prime, and then Z. So 1.96 times the square root of 2.225 times 0.775. That's all over n, which is 240. So that becomes approximately 0.053. So your margin of error is 0.053. And that's it for number 24. Okay, so for 25, I have here, let's see, make sure that okay. All right. So, okay, so for this one, it's understanding, do you understand that the probability is equal to the area underneath the curve of the probability density function? Okay, so so the figure above shows the probability density function for the random variable x. Okay, so the shaded area represents the probability that x is between 4 and 7. So what is it? So all we need to do is find the area of this. So, so we need to find the area of this and the area of this. So area for a rectangle is base times height. So the base is, so 1, 2, 3, right? Spaces, and the height is 0.10. So 3 times 0.10, which is just 0.3. That's the area of this rectangle. And then the area of this triangle, well, what's the area of a triangle? 1/2 base times height. So the base is the same, which is, 3 spaces. So in this case, base is 3. And then the height for this goes from 0.10 to 0.22. So that's just minus, so 0.12. So you just plug that in. So 1/2 times 3 times 0.12. Okay, and that's going to be 0.18. So this area is 0.18. So the total area, which represents the probability, is going to be 0.18 plus 0.3. So 0.3 plus 0.18, in other words, 0.48. That's it. So it's really not, what was the key thing, what's the key takeaway here is that probability equals area. Okay, so that was the huge one. That's basically what you needed to know for that. Okay, so number 26. We have here the lengthened days of job searches for individuals making career transitions are normally distributed with an unknown population mean and standard deviation. If a random sample of 45 career changes is taken to estimate the mean job search length, use a calculator to find the t-score that should be used to find a 99% confidence interval estimate for the population mean. So, okay, so basically we have N is 45, we have confidence level 0.99, and we want the t-score. So let's see, could you have done, there's 2 ways to do this. You guys don't have, some of you guys have the, so we could either use table, so we have a T table where we have degrees of freedom 44 and the confidence level 0.99, and then we could find the corresponding t-score. If you have inverse t, you could use it. So we would do inverse t. So against this, hold on. Okay. T, inverse T. I'm trying to find inverse T. I don't know. Do I not have inverse T? Huh. Interesting. I thought I had. I guess I don't have inverse T either. That's weird. I really thought I did. Inverse T. Okay, well, all right, that's fine. Okay, so there's another way to do it where you do the interval, T interval, and then you find the T-score that way. Because if you have a T interval, you have 0, and then you have a T-score here, and then this negative T. So that's one way to do it. So let's go ahead and do that. So we have here test T interval, and then we have our stats. We have here when let's assuming that x is 0. This is not really okay, so T interval, so 0, and then our standard deviation. Not given that either, are we? So T. And but the standard deviation is given by the square root of 45. What is that? Square root of 45, and then n is 45, and then your confidence level is 0.99. And then if you do it this way, where you put the sample square root of 45, square root of n, because we don't know what the actual standard deviation is, so we use the sample 45. Then you have one that's symmetric about 0, so then your t would be 0.2692. Okay, so what's another way to do this? I'm curious. We could find a t-table with degrees of freedom up to 44. So let me see if you guys can bear with me. I can find one here. Degrees of freedom 44. No, this one doesn't have it. This one also does not have it. 44. Usually they give you like 48, 40 and 48. Let's see here. CL of 99. Well, maybe we put a pin on this one, but I'd like to be able to show you another way to do this. But that is looking to be a little bit more difficult than I anticipated. Okay, well, let me come back to it, but in the meantime, this is how we're going to do it. But I'm pretty sure there's a way. Let me find a table that has this. So table that has 44. Okay, so that's a note to myself. Okay, so 26. So 27, we don't have all day. So 27, in a survey of 356 people who attended a local professional soccer team's most recent home game. So we have 135 said that they were fans of the visiting team. Create a 90, so we have N is 356, X is 135, and then we want a confidence level of 0.95. So this is just your interval. This is pretty straightforward. This is using one prop zint because this is a, one prop zint. So you use the function one prop z interval because you're finding the interval and you're given a proportion. So you just do a stat test and then one prop z int, and then you have x is 135, and then you have n is 356, and then your confidence level is 0.95, and then you just calculate it, and that's it. So your lower is 0.329, 0.430, because this rounds up to 0.30, 430. Yep. So, yeah. So it's stats, test, and then one prop zint. So, and then you enter this info, and that's pretty much it. All right. So a statistics professor recently graded exams, final exams for students in her introductory statistics course. In a review of her grading, she found the mean score out of 100 points was 77% with a margin of error of 10. Okay, so that's pretty straightforward. So the point estimate is 77, margin of error is 10, and they want you to construct a confidence interval. So that's just, do you know the formula for a confidence interval? That it's point estimate minus the error, point estimate plus the error, okay? So this would be something that you put in your notes. So you would do 77 minus 10, 77 plus 10. So it should just be 67, 87. Okay. Then 29. Suppose the points scored from a population of algebra tests are normally distributed with an unknown population mean and population standard deviation of 5.2 points. Okay, so basically it's asking what value of z should be used to calculate a confidence interval. So I think we've seen this question like a bunch of times and we keep doing it. I'm kind of thinking I need to go back and eliminate some questions because this is kind of repetitive. So if we know confidence level, we know alpha over 2. So what is the z of 0.025? It's just here on the table, and that's it. Okay. Yep, so that's 29. Okay, so here, the pages per book in a library are normally distributed with an unknown population mean. A random sample of books is taken and results in a 95% confidence interval of this 237 to 293 pages. What's the correct interpretation? So for this, what does it mean when you say we can say with 95% confidence that, we use this information? So we can either say, so which one is correct? We have here the sample mean. So this says that the sample mean is between this. And then this one says that every time a book is selected, 95% of the time, it's going to be this many pages. Or we estimate with 95% confidence that the true population mean is between these two. And it's actually, this is the very definition of confidence interval is, it's not that the actual 95% of the time it's this, right? No. It's saying that if we take a random sample and we create a confidence interval many times, let's say like 1,000 times or something, 95% of the time, this interval will contain the true population mean. So, if you don't see true population mean, then it's wrong. So your answer is C. All right. So given the plot of normal distributions of A and B below, which of the following statements are true? Select all correct answers. Okay, so Here we have two distributions that appear to be, cut in half on the same point. So that means that their mean are equal. So the mean of A equals the mean of B because they have the same point or the same axis of symmetry, you could say. So the means are equal. And then what else? We have that A is wider, right? So A is wider, right? So A has a larger standard distribution. Standard deviation, sorry. Deviation. So you could say that A has a larger standard deviation. So your answers to this are just C and D. Okay, and then 32. Okay, so suppose the length of words of essays written for a contest are normally distributed and have a known population standard deviation of 325 and an unknown population mean. So mean is we don't know. A random sample of 25 essays is given and gives a sample mean of 1640 words. Okay, so identify the parameters needed to find a 90, to calculate a confidence interval at the 98% confidence level and then find the confidence interval. So really just by reading, we have most of these, right? Just by reading, we say, okay, the known population standard deviation is 325, so that's that. And we don't know what the unknown population mean is, okay? So we're given a random sample of 25, okay, fine. And then we're given that a sample mean of 1640, that's that right there. So we can already fill this in, fill in most of it. So then we're given 98% confidence. So alpha is 0.02, alpha over 2 is 0.01. What is Z of 0.01? That's just 2.326. Okay, so the next thing we would need to do is calculate the confidence interval. So we would need to know the error and then to use the point estimate, which is the sample mean. So this is going to be basically the sample mean minus the error, sample mean plus the error. Okay, and then the formula for the error would be Z of alpha over 2. And since we're talking about means, it's sigma over square root of n. Okay. Here's where we could say, well, can you use your calculator? Yes, actually you could. We have a one sample confidence interval where we have sigma and we have x bar and we have n. Okay, so sigma is 325, x bar is 1640, and then n is 25. Sorry, 25. And then my C level is 98.98, and then we would calculate that. However, that's one way. So if we want to do it this way, we would use everything. So our error is going to be 2.326 times the quantity 325 over square root of 25. Okay, and that's just going to be 151, approximately 151. And so my confidence interval is going to be 1640 minus 151 and 1640 plus 151. Because it says round the endpoints to the nearest whole number. Okay, fine. So that's just going to be, so in the calculator, we get 1489, 1791. So let's see if we get the same thing. We have 1640 minus 141, 1499. That's interesting. 51, sorry. 151, that's why I messed up. So yeah, so we get the same value, 1489. And then 1640 plus 151 is the same value, 1791. So you could also have used the interval. So 1489 1791. So the interval also works. Okay. All right. Okay. So here we have population standard deviation for the weights of boxes of breakfast cereal is 0.6 ounces. If we want to be 90% confident that the sample mean is within 1 ounce of the true population mean, what is the minimum sample size that can be taken? So we need to use that formula for sample size. Z squared sigma squared over error squared. So we have this 0.6, and we have the error, it's 1 because of the word within, and then we just need z, but it's 90% confidence. So remember, 90 alpha is 0.10, alpha over 2 is 0.05. So z of 0.05 is 1.645. So then we just plug it in. So n is 1.645 squared, 0.6 squared over 1 squared, and that's just going to be, so 1.645 squared times 0.6 squared. And then it says, make sure you round up to the nearest integer. So n is approximately, in my calculator, I get 9.97, but the nearest integer is just 1. So that's just 1. Well, that worked for just 1. Okay, cool. Okay, that's 33. Okay, so 34 is pretty straightforward. It's a random sample of teenagers are asked if they want to have a sibling. The confidence interval is given by something here. It's 0.61, 0.91. And to find the point estimate, you just have to, remember, find the average. So to find the point estimate or the sample proportion, it's the midpoint. So midpoint. So it's the highest plus the lowest, so it's plus, right? It's not subtraction, it's plus. So that's just, or, either way. So since adding is commutative, so plus 91 plus 61 over 2, and that just becomes 0.76. So the sample proportion is just 0.76. Okay, so given a confidence interval, to find this, the point estimate, so be it a proportion or X bar, you just find the midpoint of these two, so the average. Okay, cool. So this is an old problem as well. So the total snowfall per year in Laytonville is normally distributed with mean 99 and standard deviation 14 based on the empirical rule. What is the probability that in a randomly selected year, the snowfall is less than 127 inches? Enter your answer as a percent rounded to 2 decimal places as necessary. So, so we have that the mean is 99 and the standard deviation is 14, right? So if we think about the empirical rule, you have here 99 is the mean. It's normally distributed. We have 1 standard deviation, 2 standard deviation, 1 standard deviation, 2 standard deviation, okay? So we want, so what is the empirical rule? So this is plus, if we add this together, we get 113, and we get 127 on this end, right? So they want the probability that the snowfall is less than 127 inches. So it's actually kind of convenient for us because if you consider the empirical rule, this area underneath the curve represents 97.5%, okay? So this is, this is 95%, sorry. This is 95% right here. But there's symmetry, so that means that the remaining 5% are in the tails. So 2.5 is here and 2.5% is here. But when they're asking for less than 127, they're asking for all the area to the left of that value. So it's really 95% plus 2.5%, giving us 97.5%. Okay, so 36, a group of friends have gotten very competitive. They find that overall, they each have won an average of of 18 games with a population standard deviation of 6 games. Okay, so if a sample of only 2 friends are selected at random from the group, select the expected mean and the standard deviation from the sampling distribution from the options below. Remember to round to the nearest whole number. So we have here n is 2. So the sampling distribution, because we're talking about means, is sigma over square root of n. That's going to be 6 over square root of 2, and that's approximately 4 games. And then since it's a normal distribution, we would say that the mean or the expected mean is equal to the actual mean. So that's going to be 18. So you have here D, and then we have here 4 for that. So it would just be C and D. Okay, and then we have an intern would like to estimate with 90% confidence the true mean number of meetings per day at the company. Assume the population standard deviation is 13. The researcher wants to estimate to be within 3 meetings. They complete the calculation this way. What is incorrect? Because they got 16. So what is the incorrect here? So they want it to be with 90% confidence, right? So just remember that n is z squared, sigma squared over error squared, right? So we have here, that's correct. The error is 3 because it's within 3. Standard deviation is 13, right? But the z-score is not 0.90, so this is wrong, right? So what value is incorrect? The incorrect is 0.90 because it's actually z of alpha over 2, right? So the correct one would actually be 1.64. So that answers the question already. All right. And then 38, according to the latest financial reports from a sporting goods store. Sorry, let me straighten this. The mean sales per customer is 75 with a population standard deviation of $6. The store manager believes that 39 randomly selected customers spent more per transaction. So what's the probability that the sample mean of sales is between $76 and $77? Okay, so we need to find mu of x bar, and then the probability. Okay, so we have here the mu of x bar, that's the same as the mean, that's 75. And then the sigma of x bar is going to be sigma over square root of n. So that's just 6 over square root of 39. And that turns out to be 0.96. So that's this one, that's the first one, that's the second one. And then to find the probability that 76 x bar is between 76 and 77, okay, you can do, oh, sorry, I didn't show that. You can do 2 things. They tell you to do, use the table to find z, and then use that way, but you don't have to do that. You could just do norm CDF. So let's go ahead and do that. So clear distribution. No. So stat. Here it is. Oh, there's inverse t. I was looking for it. Okay, so 6,77, and you use the mean that's given to you, 75, and then the standard deviation is 0.96. So you would use norm CDF instead of using the table. So no table, just use normal CDF, where you have your lower, your upper bound, and the associated mean, and then the associated standard deviation. And that'll give you your answer, 1.3. Okay. So that's it. You have 1, 2, those are your 3 answers. Okay, and then I hopefully will finish on time. 39, a bakery sells an average of 48 chocolate chip cookies with a standard deviation of 11 cookies. So, okay, so the manager of the bakery wants to make sure that they're selling as many cookies as possible each day. So she identifies when their sales are in the bottom 15%, use a calculator to find out how many cookies must be sold each day to put the bakery in the bottom 15% if the manager analyzes 30 days of sales. So then we round, okay? So, so we don't even need to have, so we just need to do, we just need to find X bar and sigma of X bar. Okay, so here we have, okay, so mu of X bar is equal to mu, which is 48, because that's the average of 48. And what else? So sigma of X bar is going to be sigma over square root of n, right? So that's going to be, standard deviation is 11, analyzing 30 days, okay? And then that's approximately 2. So we have 48 cookies, we have 2 cookies, right? And then to find X bar, we know that it says here the bottom 15%. So that means that what is a value where that value of X gives us an area of 15%. Okay, so it says, hey, what's the value of X bar, so that if I take the probability of X bar equal to this value, less than or equal to this value, it's going to be 15%. So what do we do to find that? When we use inverse norm. So we use the probability area. So the area is 15. And then what's the mean is 48, and the standard deviation is 2. So, no, sorry. So distribution, inverse norm, probability area, or the area to the left of 48, and then 2. And then you get 45.9271, but you have to round down because if you go higher, if you go up to 46, you're gonna pass that 15%. So you don't wanna do that. So we would round down to 45 cookies. So it's 45 cookies. Round down. Okay. And then here we have the speed of vehicles traveling on a highway are normally distributed. A random sample of 11 vehicles is taken and results in a sample mean of 65 miles per hour, and a sample standard deviation of 9 miles per hour. So then we say find the 90% confidence interval estimate for the population mean using the student's t distribution. So we have a random sample of 11, and we have a sample mean of 65, and we have a sample standard deviation of 9. Okay, so that means that my degrees of freedom is 11 minus 1, which is 10. Okay, so we want to find the 90% confidence interval. So let's just use T interval because you know, I'm slowing down here. Okay, so let's go ahead and do that. So clear, so second quit. Why do I keep going to the wrong thing? So stat test T interval. And what do we have here? We have our info. We have X bar is 65. So 65, plug it in. S of X is 9. N is 11. And then our confidence interval is 90%. And then you just calculate it, and there it is. So CL is equal to 0.90. Use T interval. Okay, so that's so just to stat test and then T interval. So stat and then test and then T interval, and then you enter this info. And so your lower value would be 60.008, and your upper would be 69.92. Okay, so that's that. And then I think we're getting close to the end here. So 41. 41 says what? 41 says the amount of insurance claims that a car dealership submits each year are normally distributed with a population standard deviation of 3.5 claims and an unknown mean, a random sample of 30, and results in a sample mean of 39. Find the margin of error for 90% confidence interval for the population mean. So we don't know the population mean, but we do know a couple of things. Okay, we know the 90%. We know here that we need to find. Let's see here. Let's just list what we have. Actually, we do have the population standard deviation 3.5. We don't know mu. We do know that n is 30, and we do know that x bar is 39. Okay, and then we have here 90%. We know that confidence level is 90%. So we want to find the margin of error. So the margin of error for a 90% confidence interval for the population mean. So let's see here. So to find the margin of error, we need the z-score, sigma, and n. So how do we find the z-score? So the associated z-score is equal to 0.05. So using a table, right? We have 1.6448 or 1.645. Then you just plug it into E, the margin of error, Z of alpha over 2 times sigma over square root of n. And then we just plug it in. So 1.645 times 3.5 over square root of 30. Right. And then that ends up being 1.051. And that's it. Okay. All right. City Mayor Michigan is planning the number of new snowplows he must purchase to remove the snow next winter. The average snowfall has been normally distributed with a mean of 112 and a standard deviation of 14. What amount of inches separates the lowest 20% of the means of yearly snowfall in the past 10 years from the highest 80%. Use the Z table below. Okay, so what are we doing? So we know the percentage is 20%. So we can do that. Okay, so we can work backwards. So we can have, we can find the Z-score that distributes to, that associates with 20%. So let's see here. We have the average snowfall. So we have mean is 112, standard deviation is 14. What amount in inches separates the lowest? So what means of some number is equal to 0.20. So we could do inverse norm. So inverse norm, 0.20 comma, and then the mean, and then the standard deviation. So let's go ahead and do that. So, sorry, back to this second inverse norm. We have the probability, then we have the mean, and then we have the, this. So entering 0.20, 112, 14, and then we have x is equal to, x bar should be 100 and 0.2. Did I do this correctly? Lowest 20% to the highest 20%. This percent is, it's a value that's it's approximately, did I enter this correctly? 10%. Oh, I used the wrong standard. Sorry, I need to find this first. So before I do that, average snowfall of the past 10 years has been normally distributed with a mean of 112 inches and a standard deviation of 14. What is the amount? Since it's been 100 years. Oh no, it's been 10 years. Why is it 100 years? Okay, someone's getting tired. It's 14 over square root of 10, and that's 4.43. This is what we need to actually enter here. Sorry about that. 4.43. So let's go ahead and do that. Inverse norm, 0.20, comma, 112, comma, 4.43. And that just becomes 108 inches. So this is 108 inches. But then we need to find the Z-score. So Z is equal to 108 minus the mean, which is 112, all over the sigma of x bar. So that's 4.43. So then you just figure that out. So it's 108 minus 112, it's 8 minus 112, and then divide by 4.43. And then we would get that negative, so it's minus, so 108 minus 112 divided by 4.43. And I get negative 0.9. Did I do this right? Negative 0.902. I think because this is actually a decimal, and we should keep the decimal when calculating the approximate Z-score. And it says to use the table. And the reason that it says to use the table, it wants to do what does 20% correspond to. So 20% is it's really close to here, 0.85, where so this is what it's saying. Because it's close to 0.2, it's saying Z-score is approximately negative 0.85. But if you do it in the calculator and you use, you get close to negative 0.90. So this is what it says. This is using the table, okay, where this is the area. So 120. That's the closest. Or you could do 0.84, I guess, but this is what the thing reads. Okay, so 43. Suppose weight in pounds of dogs in a city have an unknown distribution with mean 31 and standard deviation 5 pounds. A sample size N39 is randomly taken and the sum is taken. What's the probability that the resulting sum is between 1180 and 1194 pounds? Okay, so we need to find the probability that the sum is between 1180 and 1194. Okay, so we have mean 31 and we have standard deviation 5, but we need to do CLT for sums. So that means that using CLT for sums, the mean is going to be square root of it's equal to the mean of the original distribution times the number of samples. So N is 39. So it's N, M. So that's 39 times 31. This is for the sums. So that's going to be 1209. And then you have the standard deviation. That's where the square root comes in. The standard deviation for the sums is the original, is the square root of N times the original. So that's going to be square root of 39 times 5, so that's 31.225. So using this value and this value, we can find this. So we just use normal CDF, lower bound, upper bound. So lower bound is 1180, upper bound is 1194. The mean is 1209. And then the standard deviation is 5 square root of 39. Okay, and if you plug that in, that'll give you 0.1390, which is B. Okay, 0, which is B. Okay, and then we just have 2 more problems and then we're done. Okay, so I think this last one, or this one right here, we just have to plug it in and do the calculator to find the confidence interval. So you need to enter this into your list. Okay, so we need to enter this into L1. So step 1, enter into L1. So let's go ahead and do that. So stat, edit, and then L1. We have here 1203. Oh, come on. Sometimes it does that. 1203, 1553. I'm just going to really quickly enter my list here. 832, 1730, 1184, 2082, 1642, 10. Oh, shoot. Wow. Oh. 16, wait, 22. Okay, 1642. Enter 1087, 2238. 448. Okay, so then let's get out of there, and we want to do an interval. Okay, and then so we want to do T interval because we're given here we have a list, and then we want to do the sea level is 90, so we calculate that, and our interval is 1138.4, comma 1583.7. Okay, and that's 44. And then the last problem, clothing store wants to determine the current percentage of customers who are over the age of 40. So the store wants to create a 90% confidence interval with a margin of error of 0.2. How many customers should be polled? Okay, so you need to use that formula, z squared, p squared, q prime all over error. So the associated z is 0.01, and you can use a table to find that, but it's 2.326, so put somewhere table. And then p prime, we don't know, so we let p prime equal q prime equal 0.5. So we just plug it in. So n is 2.326 squared, 0.5 times 0.5 all over 0.02 squared, and that becomes 3381.4. And since it's people, okay, so we're going to round up to the nearest person, so that's 3,382. Okay. I feel like we did this problem, but hey, I can't remember at this point. My brain is fried. All right, so that's all I have. That's the entire review. Does anybody have another question? Oh, I have a question. 25, okay. Yep. 25 is this one where we found the area. Anybody else want to see another one? Could I post a recording? Yes, I could. It's going to take a while because it takes a little bit while to download, but I am going to open the midterm up. So does anybody else have any questions?
Can I say number 29, please?
I'm sorry?
29?
Which one? 43?
29.
Oh, 29?
Yes.
Okay. Okay, so I see in the text 43 is this one. And then 29, let me look for it. 29. Oh, 29 is just finding the z-score associated with 95% confidence. So, so this is 43. So Brandy, you got 43. And then 29, it's just this. 29 is just the confidence level, alpha off over 2, and then just using the table. That's 29. Any others? Anybody else want to see any before we sign off here? So 28 is this one. Oh, just plugging it in. I'm not sure off the top of my head how long the midterm is. I can't remember, honestly. I think it's maybe 30, 35 questions. No problem. Anybody else? It's due tomorrow. So after this, we're gonna have to start getting, so we'll have this one this way, and but the next one we'll have to do it within our time limit, you know, because eventually we wanna get used to doing that for the final. The final, it will have to be proctored. So I'm gonna figure out ways to do that. Yes, the midterm is in Newton. I'm gonna put it up right now. So if you guys wanna hold on a second, I'm gonna put it up and then you guys can tell me that you accessed it, okay? And then once you verify with me that you got it, you're free to go. So midterm 2. Hold on a second. Midterm 2. That was a lot of talking, TBH. And then here. Okay, so everybody go to your canvas. Give me a second. Okay. All right, if you can please go onto your canvas and let me know if you are able to see the midterm. Okay, great. So you guys can open it and start it. So interesting. Okay, great. Okay, great. I might just do. It's actually the same length. So I want to maybe take out a couple of questions, but just go ahead and get started, and it should be fine. It should be okay. Good luck, and I will see you guys on Thursday. I will see you guys Thursday for chapter 9. We're doing it. Okay. All right, guys. See you Thursday. Give me a second for quiz 8. Give me a second on that, okay? Let's see. Show. Okay, so let's see.